Hi, today we will uncover the mysteries of chemical hazards in water supply system. So stay tuned and get started. Welcome to the captivating world of chemical hazards in water. Get ready for an enlightening journey as we unravel the secrets of chemical components in water, from their dissolved and insoluble forms, and learn how to protect our water from chemical exposure risks. Our adventure begins with the basic of inorganic chemical hazards. We'll explore how rich water with minerals and elements, and how can be both harm and improve our health. You will discover the balance between beneficial and harmful substances, and how to ensure your water is safe to drink. Next, we'll dive into the realm of organic chemical hazards. These hidden components can contaminate our water, posing serious health risks. We'll unravel these organic chemicals and where it comes from and how they end up in our water supply system. Then we'll delve into the world of disinfection by product. Chlorination and other disinfection methods keep our water safe from pathogens, but they can also create harmful byproducts. We will uncover the complexity of these components and discuss the importance of proper disinfection practices. As we venture further, we will uncover the issue of corrosion. The decay of pipes can produce harmful byproducts that leach into our water supply system. We'll unravel the mystery and discuss strategies to minimize these risks and ensure safe drinking water. Our journey continues with the exploration of emerging chemical hazards. We'll look at how chemicals from healthcare products and other sources enter our water supply system, polluting it and posing new challenges for water treatment. In our final leg, we'll address the risk of microplastic and algal toxins. These hidden contaminants can severely impact water quality and health. We'll unravel where they come from and how to tackle these issues. Throughout our journey, we'll discuss the best treatment option to remove these chemical hazards from water, ensuring it's safe for consumption. Join us for this fascinating journey through the world of chemical hazards in water. Let's learn how to protect our most precious resources and ensure clean, safe water for all. Today, we'll be exploring some hidden troublemakers in organic chemicals. These snaky characters don't have the usual carbon-hydrogen bonds. These inorganic chemicals can come from nature or human activities. While some are harmless, others can cause serious health problems if they present in high amount. That's why there is special guidelines to keep these bad stuff under control. There are many invisible troublemakers, but let's focus on the most common problem makers in the world of water supply: nitrate, fluoride, arsenic, and heavy metals. When I stated heavy metals, I mean elements with high atomic weight and density at least 5 times greater than water. Think of heavy metals as super dense particles in the world of water. They are usually solid and heavy as an element in the nature, but even a tiny amount can dissolve in water. Some common heavy metals include iron, nickel, copper, and cadmium. We'll learn more about each of them later. Mercury is a sneaky villain and show up naturally like a volcanic areas or be created by factories. It's super important to keep this element level in water very low. Check the World Health Organization (WHO) guideline to see the safe amount of this element. Why? Because too much of this element can mess with your brain development, kidneys, and even your ability to have children. Nickel can exist naturally in rocks and soil, but it can be ride on polluted water runoff from factories or mines. This special metal can cause big problems if it's present in high amount, like lung or nasal cancer, skin irritation, trouble breathing, and even harm your chance of having children. Cadmium is another heavy metal danger that can show up naturally or be a result of human activities. This element can weaken your bones, damage your kidneys, and even increase your risk of cancer. They are actually different types of chromium, but the ones we need to watch out for this hexavalent chromium, CRVI. This is non-carcinogenic materials, meaning it can cause cancer. Just like the other sneaky chemicals, it can be found naturally or be produced from human activities. Copper is an essential nutrient, but even good things can be bad in excess. High level of copper in water can damage your liver and kidney. While it can cure naturally, human activities can also contribute to copper contamination. Zinc is another important nutrient, but too much of good things can cause problems. If you get a super high dose of zinc from your water, it can interfere with how your body absorbs other nutrients and lead to stomach issues. Now let's uncover the ugly truth about arsenic. Arsenic, the name itself sounds criminal, and for good reason. This element can appear naturally in rocks and groundwater, especially in South Asia countries like Bangladesh. Even tiny amount can be toxic, leading to serious health concerns like skin cancer, development issues, and even diabetes. Science tells us that high level of arsenic exposure can cause skin problems. This image is a stark reminder of the danger of arsenic poisoning. Exploring fluoride. Is it a friend or enemy for our teeth? Fluoride in low concentration, it's a hero, strengthening teeth and preventing cavities. That's why it's added to many toothpaste and some water supplies products. But too much fluoride can become an enemy, causing dental problems like fluorosis. This image shows what can happen when there is too much fluoride in your water. It can cause discoloration and weakening of your teeth. Discovering nitrate, the silent threat from farms to water. Nitrates, the troublemaker, often come from agricultural practices like using fertilization. It can contaminate water source and cause a serious condition called blue baby syndrome in infants. This image shows a baby suffering from blue baby syndrome caused by high level of nitrate in the water. The bluish color is a warning sign of this dangerous condition. Now that we have explored inorganic troublemakers, let's shift to organic chemical hazards. These are sneaky characters with a special features carbon-hydrogen bond, CH, the most living things share. There are many organic compounds, but let's focus on the big three: patch, polycyclic aromatic hydrocarbon, VOX, volatile organic compounds, and pesticides, herbicides. VOX, imagine tiny invisible bubbles forming around these chemicals. They have a high vapor pressure, meaning they easily turn into gas at room temperature, like benzene. Patch or PAHs, these complex molecules are formed from carbon and hydrogen atoms linked in a special rings shape. They come from the incomplete burning of things like fossil fuels, wood, and even tobacco. Pesticides and herbicides will give these special focus because they are a common problem, especially in areas with farming near water sources. All these organic chemicals can pose a threat to our health and the environment if they contaminate our water system. Pesticides and herbicides are often grouped with patches, but they deserve their own spotlight. Farmers using these to control unwanted insects and plants, but unfortunately, these chemicals can sometimes end up in our water. Pesticides aim for insects, while herbicides target unwanted plants, but sometimes they can harm us too. Exposure to pesticides and herbicides can directly harmful our human being, increasing the risk of certain cancers, neurological disorders, and other health problems. This image is also a reminder of the potential consequences of pesticides and herbicides contaminating in water. Now let's delve deeper into PAHs and VOX, a tale of two threats. PAHs can enter our water through industries discharge like factories or manufacturing plants. VOX, as mentioned before, readily evaporate into the air. Unfortunately, they can also dissolve in water, contaminating it. Both elements, patch and VOX, can cause a range of health risk concerns, including cancer, respiratory diseases, heart health problems, and development issues. Both materials have a direct impact on our respiratory system, increasing the risk of breathing problem. Now, let's uncover disinfection byproduct, DBP. Chlorination trihalomethane, THMS, formed when chlorine reacts with organic matter. Haloacetic acid, HAAS, chloride react with organic acid in water, carcinogenic materials, and increase the risk of bladder, risk of colon and rectal cancers. Ozone. Ozone reacts with bromide if there is a bromide present in water and forms nitrosamines ozone, and chlorine react with nitrogen present in water. It is a carcinogenic and cause a risk of birth defects and development abnormalities. Disinfection byproduct. This picture shows the danger of this product. But what is the DBP? Removal option. The removal option of DBP, it can be by chlorination in case our water system has low turbidity, while ozonation, we can rely on ozonation when water has no bromide in water. Indeed, ultraviolet or UV could be the optimum solution if there is enough budget, as UV can damage the DNA of the microorganism. UV can be advanced tools for water treatment, while there is even simple form of UV that can be used per households or small scale communities. Now let's uncover corrosion byproduct, CBP. In theory, corrosion is a process where metal deteriorate or break down because of reaction with their environment. Imagine you have an iron plate. When the plate is exposed to water or oxygen, chemical reaction happen. This reaction forms a new substance called rust. Rust is a brownish substance that forms on the surface, which is flaky and weak compared to the original iron. Metal in general has tendency to lose electron and experience oxidation when placed in electrolyte solution or exposed to oxygen. Ferric oxide, zinc or galvanized and copper pipes all can accumulate in pipes and affecting water quality in general. So corrosion in pipes lead to taste issues and risk of kidney and nausea for long-term consumption. Let's consider this aspect to protect our communities. The best way to overcome this problem, the corrosion, is by renew our pipes, either adding anti-corrosive materials in the pipes or using different materials like PBR or HDPE. It is also necessary to control pH and metal concentration in water. Now we need to discuss some emerging chemicals which is considered as a public health concern, especially in modern society. Key components are PFAS. PFAS stands for per and polyfluoroalkyl substances. PFAS are chemicals used to make products resistant to water. They are found in things like popcorn bags, pizza boxes, and some firefighting foams. PFAS are sometimes called forever chemicals because they don't break down in the environment or the human body. This means they can build up over time and potentially cause health problems. Also, personal care products like our daily usage of chemicals during bathing, such as lotions. Personal care products are risky for human consumption. Besides, medical treatment or pharmaceutical treatment has high level of toxicity. All these kind of chemicals should not be present in our water drinking system, and as it is consists of toxic materials for human. Microplastic is our future enemy, the threatened items in our water supply system. Microplastic can be large or small. It basically divided into primary and secondary items like plastic bags and microbeads. Microplastic impacting biodiversity and ecosystem and harm our body, as it has risk of toxicity and pathogens development. Algal toxins are also a health concern for human. Most common components of algal, anatoxins, saxitoxins, and microtoxins. So we need to ensure that our water is safe from all these chemicals. But how to remove chemical hazards from water? Best option indeed is reverse osmosis, but it is expensive option. ionic exchange is a great option to remove specific chemical hazards like iron, for example, while activated carbon recognized as the best option for low budget. For arsenic and fluoride removed from water, both can be suitable for reverse osmosis, activated alumina, and activated carbon. For low-income setting, activated alumina can be made in simple options for household purpose. Another method to remove fluoride rather than activated alumina filter for small-scale communities that rely on using filter made from animal bones is commonly used in African countries. But what about the removal of microplastic and algal from water? Luckily, sand filtration or physical filtration proves sufficient and efficient in removing algal and microplastic, so it's more cheaper option than advanced treatment option. That's the end for today, and see you next time.